When you're coding with Kiro, the agent may have to do a lot more than read and write files. It may also have to search documentation, call cloud APIs, generate diagrams. But how does that actually work? In this video, we'll understand how Kiro uses MCP servers and uses the tools therein to extend its capabilities. Kiro agents use few things to accomplish the task you gave it. First is a model that you selected. This provides the knowledge and reasoning that your agent needs. Next are a set of built-in tools that let Kiro act on your code. But sometimes the task needs more than what built-in tools can accomplish. That's what MCP servers add. They extend the agent's reach beyond the IDE. For the rest of this video, we'll focus on how you connect Kiro to MCP servers and how the Kiro agent discovers and uses them. As a developer, you add MCP server details to the Kiro config file. Kiro allows you to add MCP servers at two levels: a user config that applies to all your projects, a workspace config that's project specific. For each server, you need three things: the command to start the MCP server, the arguments it expects, and any environment variables like API keys or log levels that the MCP server needs. Where do you get this information from? Well, from the MCP server's documentation. It'll tell you exactly how to use a server, and most servers have a quick start section with a config you can copy directly. So you have added your MCP servers to the config. From here on, we will see what happens when Kiro starts up and discovers your tools, how the agent decides which tool to call when you send a prompt, and how that call gets routed to the right place. When Kiro starts up, the first thing it does is load its built-in tools. Things like file read and write, code editing, shell commands, and others. They come bundled with the IDE and are always available. Next, Kiro reads your mcp.json configs. For each configured MCP server, it connects either by spawning a local process for stdio transport or by making an HTTP connection for remote servers. For each server, Kiro gets back the name, description, and input schema for every tool that server provides. And once all servers have responded, Kiro has a complete set of available tools, built-in plus MCP. Now Kiro has built-in tools plus everything from your MCP config. But here's the thing, every tool definition you add consumes context. So don't just add every MCP server you can think of. Be intentional. Your user config should have the servers you genuinely need across all your projects. Your workspace config should have only what this specific project needs. If a server isn't relevant to the project, don't add it to the workspace. Keep your toolset lean. Kiro Powers gives you the ability to load tools dynamically, but that's a topic for another video. So when you send a prompt to Kiro, it puts together everything the model needs to work with. Your system prompt, your steering files, which is a topic of another video, the conversation history, and any open file or workspace context. On top of that, it includes every available tool definition, both built-in and MCP, and this is attached as JSON schemas. All of this goes to the LLM in a single call. And now the model can see your prompt alongside every tool it could potentially use, and it decides which one, if any, is the right fit for what you're asking. If the agent decides it needs to read a file, edit code, or run a shell command, it calls a built-in tool. Kiro executes it locally. No network call, no external process, and the results flow back to the agent. At this point in time, the Kiro agent evaluates, am I done or do I need to call another tool? This loop continues until the agent does everything it needs to respond to your prompt. And if the agent needs some external knowledge or skills, say for example some documentation, some data from a cloud API, or maybe even a diagram building skill, it calls MCP servers and uses its tools. This is where routing happens. Kiro looks at the tool name, identifies which MCP server owns it, and forwards a call to that MCP server. The MCP server executes the tool and returns the result. Kiro passes it back to the agent, and the same loop continues. The agent evaluates whether it's done or needs another tool to get the task to completion. But sometimes the agent's LLM has enough context to answer directly, no tool call needed. It reasons over the prompt and the available tools, decides none of them are necessary, and returns a text response. Kiro passes that straight back to you. By default, Kiro asks for your confirmation before running an MCP tool. But for tools you use frequently and trust, you can add them to the auto approve list. For example, once you ask Kiro to trust the search docs tool, it will be added to the auto approve list. And subsequent calls to the search docs tool will not need your explicit approval. Kiro will still ask you for an approval for all other tools. And by that, you stay in control of which tools you run freely and which ones need your approval. And that's a complete picture of how Kiro uses MCP servers. Tool discovery happens at startup. Tool selection happens on every prompt. The LLM sees all available tools and autonomously decides which one to call. An invocation is just routing. Now, if you're connecting many MCP servers and noticing context pressure, check out Kiro Powers. They solve the bloat problem by loading tools dynamically on demand. But that's for another video. Thanks for watching. If you have questions or want to learn more, check out the Kiro documentation. Happy building.